Group 29, and our topic is the bioremediation of oil-contaminated water. Oil contamination in water can have major and lasting impacts on the surrounding ecosystem. When oil enters marine environments, the lighter hydrocarbons are broken down by abiotic weathering processes, as seen here. Meanwhile, the remaining heavier hydrocarbons can linger in the ecosystem. In terms of natural processes, these heavier hydrocarbons can only be broken down by oil-consuming microorganisms. This process is referred to as biodegradation and forms the foundations for the principles of bioremediation. Bioremediation involves increasing the rate of biodegradation and can be divided into two categories: biostimulation and bioaugmentation.
Let me talk about the two cases of oil spill. First, the 1989 Exxon Valdez oil spill in Alaska. Approximately 41 million liters of crude oil contaminated the shorelines. Biostimulation method was used by adding fertilizers in the contaminated area to stimulate the growth of the oil-eating microbes and increase the rates of biodegradation. Another case is the Gulf of Mexico oil spill, commonly known as the Deepwater Horizon in 2010. About 800 million liters of oil was leaked into the water. Bioaugmentation method was implemented by introducing cultivated microorganisms into the spill area to accelerate the degradation of the oil.
In bioremediation, a mixed population of broad enzymatic capacities are required to degrade complex mixtures of crude oil. Petroleum hydrocarbons can be divided into four classes which have different rates of biodegradation: linear alkanes, branch alkanes, small aromatics, and cyclic alkanes. Shorter chains are easier to bioremediate as compared to long branch cyclic alkanes. Now, there are several factors that limit the rate of biodegradation, in which temperature and nutrients are the most important ones. Firstly, temperature. Bioremediation generally decreases with decreasing temperature, and the highest rates are observed between 15 to 20 degrees Celsius. Secondly, nutrients such as oxygen, nitrogen, and phosphorus are crucial for successful biodegradation. Oxygen is abundantly available in the atmosphere, however, nitrogen and phosphorus are externally added to marine environments.
Now I will talk about the chemical reaction involved in the bioremediation. The most rapid and complete degradation of the majority of the organic pollutants, such as the oil contamination, is brought about under the aerobic conditions. See this graph. This graph is talking about the principle of the hydrogen carbonate. When you add enough oxygen in these systems, the hydrogen carbonate will totally become the oxygen and carbon dioxide, which is very environmentally friendly. Some chemical material will provide, such as the iron 3+ to substitute the oxygen to accelerate this redox reaction. So this is the chemical reaction.
In conclusion, bioremediation creates minimum disruption to the surrounding ecosystem.
However, breakdown of hydrocarbons is sequential, so it can be time-consuming.